Welcome. My name is Mrs. Cologne, and I am a STEM, science, and math teacher for the Early Learning and Fitness Academy. I want to give you a 5-minute sneak peek on what your students might learn in my class. I would like to briefly go over 2 STEM experiments that I would use for pre-K and 6th graders, respectively. First, I would use a Fizzy Rainbow with the pre-K students, where we are using baking soda, food coloring in a rainbow fashion. Now and also vinegar. Let me switch cameras. So you can see that I'm using baking soda and food coloring. And you can see here what I've done here to arrange it. You can see that it is rainbow and food coloring. And I had the vinegar here in this little type of syringe type thing. And I would ask them, what do you think would happen once I add this vinegar to it? And we would come to the idea that a change would happen, a chemical change. Of course, we as adults know that baking soda is a base and that vinegar is an acid. And when they get together, they neutralize each other. And we can see that we get a fizzy rainbow. It's pretty cool, pretty amazing. So anyway, then we would move on to the pre-K experiment. 6th grade experiment, excuse me. I gotta do a little bit of cleaning house here for the 6th grade experiment. Let me do that super quick here. Okay. Bring this over. Okay. And now I'm going to switch back. I'm going to share my screen. So I only have a few minutes left. And I'm going to share the screen with you. Okay, so hello again. So we're going to talk about a STEM density experiment with the 6th graders. So you can see in my shared screen here that some pictures of boats, and that boats are able to float because they are less dense than the water surrounding them. Although the steel that makes up most ships is denser than water, the overall average of a ship's density is less than water. So we see the pictures of the ships, the rowboat, which might be able to hold 5 to 10 people or maybe more, and the aircraft carrier, which can hold whole planes and whatnot. And when we think about it, we take it for granted, but it's actually quite amazing that they don't sink. It's just amazing. So why is that? Well, we already said it's because of density. Let's think about why. Why is density so important here? There is a lot of air inside the ships, and that air has a very low density. When we average this with the high density of steel, we can get an average density that is relatively low. Let's get into a little bit of math. D is equal to M over V. Density is equal to mass over volume. D is density, M is the mass, that's the weight of the object basically here on the scales we have on Earth, and V is the volume. Volume is the amount of space the object takes up. There's some pictures. I'm going by it quickly. We only have a few minutes. We'll discuss this with the kids. We talk about the density of pure water, and we do some math and some division, and we discuss whether the object would sink or float based on the mathematics. And then we get to the experiment. Everyone in the experiment would get a 15 by 15 centimeter piece of foil. No one can take away from their piece or add to it. So everybody has the same mass, the same weight of foil, and they get the same pennies and everything else, and the same student worksheet, which I'm reading to you, or I'm scrolling through rather quickly. The challenge here is to test if you can build a foil boat that can float and support as many pennies as possible. And I will have them answer some questions and also do their drawings. Now, I've already done some drawings here for my own boats. I have a 10 centimeter by 10 centimeter by 2 centimeter. I have 2 other drawings, but I'm going to use one other one for the sake of brevity, a 6 by 7 by 4.5 centimeter. And they would do the same, and they would draw it and everything. And here are my boats. This one is the 10 by 10 by 2, and this one is the 6 by 7 by 4.5. So these are the 2 boats. They weigh the same. They're made with the same stuff. Okay, so we go down here, look a little more. And so then I would have them write down how many pennies each one can hold. And I'm going to switch cameras again. And we would, of course, accumulate the data because we're good scientists. And we also can see here that this boat can float. I'm not going to bother you with how many pennies, with showing you how many pennies, but I will show you my chart. And this one can float as well. But how many pennies can they take on? Well, let's see. Let's go back. And I've come up with the chart already because I've done this experiment many times. And of course, we would do it live with the students. I would do it live with the students. Size of boat, number of pennies without sinking. The 10 by 10 by 2, my 10 by 10 by 2 could hold 40 pennies. And my 6 by 7 by 4.5 could hold 22 pennies. So why is that? Aside from like making something that might have a hole in it or has a leaky side or something, why? Why would this one be able to hold more than this one? Well, remember the equation, D is equal to M over V, or density is equal to mass over volume. We know that the mass of both of them are the same. Why is this one able to hold more than this one? Maybe it's because of the volume. What is volume? Volume is the amount of space it takes up. Which one can take up more space? This one. This one has a higher volume. And so we would come to the conclusion, as volume increases, density decreases. And then to drive it home, we would look at the picture again of the boat and the aircraft carrier. And we would have a little bit of fun. Switch cameras again. And we would look at these 2 toys. This toy and this toy. This toy is an old-fashioned, heavy plastic toy. It has some weight to it. I played with it as a little kid. And it's made of solid plastic. So because it's made of solid plastic, what does it not have in it? It doesn't have air, and air is very low in density. So what do you think will happen if I drop it in? Look at that, it goes right to the bottom. Let's look at this one. This one is a tub toy. This one has a lot of what in it? It has a lot of air in it, which is very high or low in density? Low. Let's see what happens. It floats. Wow. Well, that's it. Okay, I had a lot of fun. Bye-bye.